For question 8 is a question more on exponential and log equation. The last part for this question is something on graphical solution. But it will also involve some of your technique for logarithm. Okay, so for 8a, it's an exponential equation. So some students get stuck on 8a if they forgot that there is a method for substitution. So if you forgot that there is a method known as substitution, you will get stuck on this part. So once you know that there is a substitution, you will be able to get a quadratic equation. So if you solve it as a quadratic equation, that will be quite easy. So do your normal quadratic technique, you should be able to get 2 answers. So the trick will be, if you are using the method of substitution, don't forget to replace that. So your substitution should be written. Ultimately, your job is to find x, not to find k. So k is just something intermediate. So if let's say you do remember that you do a substitution to get through this question, okay, and if you are here and you forgot, so here will involve the technique of taking ln on both sides. So you insert a ln on both sides. That allow you to bring down the power. And ln e has a value of 1. So essentially, it's just pressing calculator. So try doing the same thing here as well. But here you will get a math error. That's why this part is actually rejected. So if you do a ln both sides, you will get this, there's a math error. So that's why that part of the question is rejected. Okay, so the next one is the log equation. The first thing that you observe from log should be, are they the same base? If it's not the same base, there should be some change of base. So if you observe this equation, the only one that is not base 2 is actually this. So the only one that is not base 2 is only this. You can make use of the change of base formula. So our typical change of base formula is usually like this. So we will do a change of base. So there is another one that actually come from changing it to base B. So if you want to change to base B, you will get a 1 over. So I would like you to observe this part. So this one is equal to this. So you can actually go backwards. So I'm going to go backwards to help in this portion. So if you take a careful look, 1 over log 8 2. If I apply the backwards, I will get a log 2(8). So I'm applying this onto this question. At the same time, if you want to, you can also change it to log 2(2). So if I apply this, I will get a direct log 2(8). Then that will be a lot shorter. So log plus log plus log, okay, will become a multiplication. It will be a 2y times x times 8. And you will get a 16y. So where you got same 1 log on each side, you can compare both log. So when you compare both log, you will get a simple equation for you to work with. So that will be how I approach this question. Part C is a bit more difficult. So this one is the same idea from EMAth. So from EMAth, there's this thing called graphical solution. So it's the same thing. So I would like to solve an equation through the graph. So if I would like to solve an equation through the graph, I need to make use of simultaneous equation. So this will be the equation. So I would like to solve this equation, but I would like to solve it from a graphical method. So I need two equations so that I can make use of the intersection. That means, right, the solution that I have will be from the intersection. So in a general idea, in a very big idea, the method will be from the equation that you would like to solve. You are going to manipulate until you get two graphs equal to each other. So until you get two graphs equal to each other, and then that will be the intersection of the two graphs. So usually they will have one graph that is already given. So like in this question, the graph that is already drawn, supposedly you imagine a graph that has already been drawn. So I will manipulate my equation until I get the graph. I will manipulate the equation until I get the graph. And usually this will be the other straight line that you will obtain to intersect with the graph. So that is the big picture first. Okay. Then in this question, right, they mentioned about they would like you to make this the subject from the equation. And hence, so they are guiding you. They would like you to make Ex over 2 the subject from the equation, and then slowly that will help you to get to the manipulation. So how am I going to manipulate this? So from the equation, the equation looks rather complex, but it is not so difficult after all. If you still remember what is ln E? Ln E is base E. So ln E is base E. You can change it to indices form. So e to the power of x is equal to this. E to the power of x is equal to this. So you can do it this way. But then in this question, right, my aim is to make e half x a subject. So if my aim is to make e half x a subject, okay, I can do something else first before I change it out to index format. So I can change it out first. Okay, I will show you two ways. So in this case, I change to base E. Okay, I can bring down the power first. I can bring down the power first. And I divide over. I can bring down the power first. And then I can divide over. So when I change, I will get a E half X. Another way will be the one that I did just now. I did a direct changeover. So I get a E X. So if I get an EX and there's a whole fraction with a square, I can choose to square root both sides. So it's your choice. So I can choose to square root both sides, but you do need to remember that square root has a power half. So you come back to the same conclusion here. So you make E half x the subject. So these are the two methods that you can make E half x the subject. And then subsequently, whichever method that you use, you are going to try to get your graph equation. So if you want to try to get your graph equation, you look at your graph, you need a multiplication of 3. So if you need a multiplication of 3, you can multiply 3 on both sides. You need a plus 4, you simply introduce a plus 4 on both sides. So that will lead you to the graph equal to 2x plus 11. So this will be the graph intersect with the straight line. So the straight line that the question one is 2x plus 11. Okay, so this method is also applicable in EMAP. The method is the same. You manipulate the equation from the equation that you would like to solve to get to the graph, and the subsequent one will be the straight line that get you the intersection. So the intersection ultimately will give you the solution that solve the equation.